In this video, we are going to tackle a very common but quite confusing type of questions in physics. It's the ratio and proportional problems. These questions are all about the comparison. Instead of calculating a final number, you are figuring out how a change in one variable or multiple variables would affect another. For instance, you're asked what happens to the force if you cut the distance in half, or how does the pressure change when the temperature is tripled. These problems can look intimidating because you don't have any values to calculate. It's easy to feel stuck and wonder where to even begin. But don't worry, we're going to break down the exact simple steps you need to follow to solve any of them. Let's jump straight into the example and see this method in action. Imagine this scenario. We have a ball rolling down a frictionless incline, starting from rest. The height of that incline is h, and the speed when the ball reaches to the bottom is v. The question is, if we cut the height of the incline in half, making it 1/2h, what is the new speed? We have four choices. A, the new speed will be twice the original speed, 2v. B, the new speed will be the original speed, v. And C, it will be the square root of 2 times the original speed. And D, root 2/2 times v. The very first step in any ratio or proportional problem is to clearly identify the required variable. So what is being solved for, or what is being compared? In our example, we are ultimately looking for the final speed of the ball at the bottom of the incline. That's the required variable we need to find, right? Now let's put the ratio step on hold for a second. Imagine you just had a basic physics problem. If I told you the height was, say, 2 meters on a smooth, frictionless ramp, how would you actually calculate that final speed v? Well, since we are dealing with a smooth, frictionless ramp, we can keep things simple and use the conservation of energy. And that means the total energy at the top equals the total energy at the bottom of the ramp. And that allows us to set up a simple equation. Energy at the top equals the energy at the bottom. At the top of the ramp, since the ball is starting at rest, its speed is 0. And this means the kinetic energy is also 0. All the energy is stored up as gravitational potential energy, which is written as mgh. When the ball reaches the bottom, the height h is 0. So the potential energy is gone. And all of that initial potential energy has been completely converted into kinetic energy, which we can write as 1/2 mv squared. Now we need to isolate v, which is our required variable. The first step is easy. Since the mass m appears on both sides, we can simply cancel it out. So the speed has nothing to do with the mass of the ball, right? The next step is to get rid of that fraction. We can do that by multiplying both sides by 2, and this gives us the equation 2gh equals v squared. And finally, to isolate v, we just take the square root of both sides. Our final solution for the speed is v equals square root of 2gh. So we've nailed down the key equation. The second step is to identify and list only the variables that are on the right side of the equation for the two situations. The only variable on the right side is the height h. 2 and g are the same in both situations. They are constants that will eventually drop out when we set up the ratio, so we leave those constants alone. The height h is our independent variable that eventually drives the change. Now let's list the variables in both situations. For the first situation, we have h1 equals h, and for the second situation, h2 is 1/2h. This is pretty straightforward, right? The next step is to substitute those variables into our key equation to find the speed for each situation. For the first situation, let's call the initial speed v1. And v1 equals to the square root of 2gh1. When we substitute h for h1, we get v1 equals the square root of 2gh. So for the first situation, the speed when the ball reaches the bottom is root of 2gh. Now for the second situation, let's call the new speed v2. v2 equals square root of 2g multiplied by h2. Now we substitute 1 over 2h for h2. So we get v2 equals square root of 2g multiplied by 1 over 2h. The 2 in the equation and the 1 over 2 in the height cancel each other out. So the new speed when the ball reaches the bottom is square root of gh. Alright, now we have the speed for both situations. We are ready for the next step, setting up the ratio. We do this by dividing the second speed by the first, v2 over v1. This calculation directly gives us the ratio of the new speed to the old speed, which tells us exactly how many times bigger or smaller the new speed is compared to the original one. So v2 over v1 is the square root of gh divided by the square root of 2gh. Since both the numerator and denominator are square roots, we can combine them and put both under a single large square root. And this gives us square root of gh over 2gh. Look inside the square root. Since both the numerator and the denominator share g and h, we can cancel them out. This leaves us with a simplified ratio. v2 over v1 is square root of 1 over 2. Or we can rewrite it by taking the square root of the numerator and denominator separately. This gives us 1 over root 2. In math, we normally prefer to rationalize the denominator, meaning we get rid of the square root on the bottom. We do this by multiplying both the top and the bottom by root 2, and this leaves us with the final simplified ratio, root 2 over 2. To solve for the new speed v2, we just multiply v1 to the other side of the ratio equation. This gives us v2 equals 2 root 2 over 2 multiplied by v1. The final step is the easiest one. We just need to replace the variable v1 with the value given in the problem. The problem stated that the original speed, while the incline's height is h, is simply called v, right? So we just replace v1 with v in our final ratio equation to get the new speed v2 in terms of the original speed v, right? Therefore, we have v2 equals root 2 over 2 multiplied by v. So going back to our options, you can confidently choose option D.